Welcome to this session where we are doing physics, and the topic we're going to cover is simple pendulum. Let's understand simple pendulum. Okay. Just a moment, please. As we commence. Okay. Let's begin. We're doing simple pendulum. So, we need first to define what simple pendulum is. What is a simple pendulum? So, when you're talking about a simple pendulum, it is just a mass this is a mass, or we can say a bulb suspended it is just a bulb or a mass. Okay, a bulb or a mass suspended by a rope or a string. Okay, that is what simple pendulum is. So I can have a structure here. This, let's say this is a fixed surface. Okay, so this is a fixed surface. Then we have a bulb there. Let's say it's swinging. Okay, let's say this is point A swinging to point B. So that is a bulb, a pendulum bulb. Then that is a string. So this is basically how a simple pendulum is. It has a fixed surface or fixed point. Then there is a bulb hanging. Then we have a string. Okay, so this bulb is swinging. It is making what are known as oscillations, of which we'll talk about what oscillations are. So this is how a simple pendulum is. So now let's look at the importance of this simple pendulum. So this simple pendulum, let's say importance or application. So this simple pendulum was used to measure time. Okay, was used to measure time. Let's look at now the important aspects you must understand. You need to appreciate these following terms. We'll start with period. What is period? So period is just the time taken for a complete number of oscillation. Okay? Time taken for complete number of oscillations. So that is what period is. It's just the time taken for complete number of oscillations. So period is noted by the capital letter T. Okay? That is what period is. And it is measured, since we are saying period is time taken, so it is measured in seconds. Okay? Time is measured in seconds, so period also is measured in seconds. The second term we need to appreciate is what an oscillation is. What is an oscillation? So an oscillation is just a complete swing, okay? A complete what? Swing. How can you know that this is an oscillation? Let's say we have a pendulum, a simple pendulum. Then we have a bulb there. Then we have point A there, point B there. So how do you measure an oscillation, or how do we count an oscillation? So this is the starting point. So if a pendulum bulb moves from that point, it moves from that point to that point, then it comes back to the same original point, you count as the one oscillation. So that is how to count. So it has to go and come back to the same point. That is an oscillation. Let's understand the third term, which we are calling frequency. What is frequency? So frequency is denoted by the symbol small letter f. Okay? It is denoted by a symbol small letter f. So what is frequency? So frequency is just the number of oscillations divided by the time taken. Okay? Frequency is number of oscillations divided by the time taken. So that is what frequency is. So what is used to measure frequency? So this frequency we are talking about is measured in hertz, okay, or in per second. In per second, like that. Seconds to the power -1, that is a per second, or in hertz, like that. Okay, so let's now look at the relationship between period frequency, and also the number of oscillation. So we have this formula: period is equal to the time taken over number of oscillation. Okay, where t is the period in second, then that is capital letter T, small letter t is the time in seconds also, then n is the number of complete oscillations, that is n. We can manipulate this formula to suit also for frequency. So frequency, we said it's the number of oscillation now over time. So that is the formula you can use if you want to calculate frequency. But you see, this is just the opposite. If we say period is equal to the time taken over number of oscillation, and frequency, we are saying it is the number of oscillation over time, have you seen that there is just the opposite? Like with frequency, we are just interchanging. Number of oscillation goes on top, then then the time comes at the bottom. So what can we say? We can say that frequency is just the inverse of period. Okay, and also if frequency is just the inverse of period, have you seen that frequency is also the inverse of period, and also period is also the inverse of frequency? So we can say period is also the inverse of what? Frequency. What does it mean? If you have frequency, you can easily calculate what? The period. If you just have frequency. Let's look at an example. Let's say the frequency for the pendulum bulb is let's say 0.5 Hz. Then what is its period? So how can we work out this? So period is just the inverse of the frequency. So I'm going to say 1 over 0.5. And what is 1 over 0.5? That is a 2 second. So that is how you can calculate the period given the frequency. Now let's look at this pendulum bulb. Let's try to understand something on simple pendulum. How do you determine the number of oscillations? For example, let's say this is on the middle. Like that. So this bulb is swinging, but initially it has at this point. So that is the starting point. So if a bulb moves, let's say this is point A, the starting point, this is point B, and that is point C. If the bulb moves from this point to that point, okay, from this point just to that point, it makes a quarter. So the number of oscillation is just a quarter. If it moves again from this point to that point, it makes another quarter. Then if a bulb moves from this point C to point B, it makes another quarter. If a bulb moves now from this point from B to A, it makes another quarter. So discover that one complete oscillation, for it to be complete, one oscillation is from point A to C and also back to A. This is when it will make 1, because 1 over 4, quarter plus quarter, that is half, plus quarter, 3/4 plus quarter, that is what? 1 now. So it makes a 1 complete oscillation if it moves from point A to C, from point A to C and back to A. That is when it can make one complete oscillation. But if it just moves from point A to point C, that is just half. Okay? So let's try to understand something. So let's say this is the question we've been asked. To say calculate the period if the pendulum bob moved from point A to C and back to B. If the pendulum bob moved from point A to C, so it moved from point A to C, then to B. So it moves like this, it goes to C, then it comes to B. So we need to determine how many oscillations has it made. So we said that is quarter. It has also made quarter there, and coming from C to B, it has also made another quarter. So what is the number of oscillations? So to determine the number of oscillations, we're going to say 1 over 4, which is a quarter there, plus the other quarter which is there, plus the other quarter which is there. Okay? So what are we going to find? So n is equal to, the common denominator is a 4, so 1 plus 1 plus 1 plus 1 plus 1. We'll discover that n is equal to 3 over 4. Now let's say this pendulum bob took maybe 0.75 seconds. That is the time. So let's say the time is 0.75 second. How can you calculate the period? So you're going to use the same formula. Period is equal to the time taken over number of oscillation. So the time is 0.75 second over the number of oscillation. The number of oscillation, it is 3 over 4. So what is the period? If we divide 0.75 by 3 over 4, it should give a 1. So the period is 1 second. Let's say you were asked also to determine the frequency. So what will be the frequency? So we said frequency is equal to the number of oscillation over time rather. So frequency is equal to the number of oscillation is 3 over 4. 3 over 4 divided by the time, that is 0.75 second. So what would be the frequency? So I'm going to say frequency is equal to 3 over 4, that is 0.5 divided by 0.5, that is just 1 per second. Second to the power negative 1. This is a per second. But you can also say 1 hertz. Okay? If you don't want to go about this way, you can just say frequency is just the inverse of period. So since we have period to be 1, you're going to say 1 over 1, which is equal to 1 hertz. Okay? 1 hertz. That is the frequency. Let's look at another example whereby you have a simple pendulum So this time around, this simple pendulum just moved from A to B. What is the number of oscillation as it made? It did not come back to A again. So we said if it just moves from the starting point to the final point where it's ending, but it doesn't come back, then it makes a half oscillation. So how can we calculate period given the number of oscillation to be half? So we're going to say period, let's say the time it took is, let's say 0.4 seconds. How can we calculate this? So we're going to say period is equal to the time taken over the number of oscillation. So period will be equal to the time taken is 0.4 second over the number of oscillation is just half. So how can you find the answer? So we're going to say period is equal to 0.4 second over half is just 0.5. So what is the period? So 0.4 divided by 0.5, that should give a 0.8. So this will be in seconds. What I've done basically there, it's I've just converted 0.4 is 4 over 10, then multiplied by, since we are dividing by half, you just multiply by the reciprocal, which is 1 over 2 over 1, and the answer will be 2 there, it's 1, 2 there, it's 5. So we have 4 over 5. So 4 over 5 is just 0.8, because 4 into 5 into 4 is 0. We put a 0 there. 5 into 40 is just 8. So that is how I found the answer to be 0.8 seconds. But how can you find the frequency given the period? So you just say frequency is equal to 1 over period. So frequency will be equal to 1 over, what is the period? It is 0.8. So what is the frequency there? So frequency will be equal to what? Okay, let me just get rid of this part. So what will be our frequency? So our frequency will be equal to 1 over 0.8. So we can say frequency is equal to 1 divided by 8 over 10. Okay, then we can say frequency is equal to, this is same as 10 over 8, and 10 over 8 is equal to, that is 1 point, remainder 2, we add the 0, that is 16, that is 2, remainder 2 again, remainder 4, that is, we add the 0, that is 8 into 4, that is, should be 5. So the answer is 1.25 per second, which we can say 1.25 hertz. So that is how we can determine the frequency. Now let's look at this formula, which relates period with the length of the bulb, the pendulum bulb, and also the gravity. So one thing you need to understand even before I talk about this is that when you're measuring the length of the pendulum bulb, when you're taught to measure the length of a pendulum bulb, so let's say this is the pendulum bulb, then you've been asked to determine the length. So you measure the length from the fixed point, there to the point, like to the middle of the pendulum. So let's say the middle is there. So you measure this length to the middle of the pendulum bulb from the fixed point. So that is the length of the pendulum bulb. So from the middle of the pendulum bulb to the fixed point. So that is how you can determine the length. Now let's look at the formula which relates period with length. So we have period is equal to 2 pi square root of length over gravity. So what does this formula try to tell us? This formula tries to tell us that period is direct proportional to the length. Okay, period is direct proportional to the length, but this same period is inversely proportional to the gravity. So what does it mean? If period increases, if you increase the length of the pendulum bob, even the period will increase. If you decrease the length of the pendulum bob, even the period will decrease. But with gravity, if gravity increases, for example, you move from moon to earth where the gravity is higher, which is 9.81 meters per square second, you discover that even the period, or if you move from moon to earth, the gravity is higher than that of the moon. So the period will decrease, because when gravity increases, the period of the pendulum decreases. But when gravity decreases, the period of the pendulum increases. So when you go to the moon from Earth, where the gravity is, let's say, 1/6 of that of Earth, you discover that even the period of pendulum will increase, because the gravity has decreased. Okay.